Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler, and today I will solve another problem and show you that not always the average speed uh, is really the average, is really the mean. So let's take a look on the example. So suppose that somebody is riding a bicycle and first half of a distance, he is riding with speed v1 30 kilometers per hour, and the second half of distance he is driving 20 kilometers per hour. The text of the problem will be in description of the video. And the question is, what's the average speed in the total trip? So the answer, automatic answer would be that it's 25, just the arithmetic mean of this 25 is just in the middle between 30 and 20. But I will show you why this is not a true answer. Okay, so let's draw it. So the biker starts here and he rides with speed 30 kilometers per hour, and he covers distance s1 in time t1. And then maybe he arrives to another town, and then maybe he is tired and then he cannot ride so quickly, or he moves, he turns back and now he rides against wind. Doesn't matter. Anyway, the second part of distance s2, he travels in time t2 with speed 20 kilometers per hour. And it said that this is half of way, so half distance. So which means this is half distance and this is half distance. So this means that the distance s1 is the same as distance s2. So for simplicity, let's call them s, common distance s. So our task is to calculate the average speed. So average speed, our best known formula, total distance divided by total time. So total distance is just s1 plus s2, so distance of first part plus distance of second part, and also total time is time of first part plus time of the second part. And we know that s1 equals s and s2 equals s, so s plus s, it will be 2s divided by t1 plus t2, which doesn't look good at all because we don't know what is s, we don't know what is t1, we don't know what is t2, we know nothing. So how to deal with this? So let's focus on the first part. So for the first part, let's write the same equation. So here v1 is s1 over t1, and let's calculate t1 out of this. So if you rearrange this equation, so you just multiply by t1 and divide by v1, so you get that t1 equals s1 divided by v1, and we know that s1 is just s. Okay, and by analogy you can write the same for second part and get that t2 is s over v2. These expressions you can plug in here for t1 and t2. So let's see. So now it's 2s divided by, instead of t1 I have s over v1, and t2 is s over v2. And now mathematical calculations. So look what we have. We have 2s, and here you have s, and here also you have s. So you have common factor, and here is 1 over v1 plus 1 over v2. Okay, now look, here is just multiplication, and here is multiplication by this bracket. So s cancels out, and what you get? You get 2 over 1 over v1 plus 1 over v2. So look, from the form in which we knew nothing, we finished with the formula in which we know everything, because v1 and v2 are our data. So now let's just plug in the numbers. So it's 2 divided by 1 over 30 plus 1 over 20. Now common denominator, so it will be 60 plus 60. So here I'll multiply by 2, here I multiply by 3. So 2 plus 3 is 5. So you have 2 divided by 5 over 60. So in order to divide by the fraction, you multiply by inverse of it. So what you have 2 times 60 over 5. So it's 120 over 5, and it's 24 kilometers per hour. And as I mentioned, it's not 25. So why we get this surprising result, which is not just arithmetic mean of the two speeds? This is because the first part is half of a distance and not half of a time, which means that you write with greater speed for shorter time, and with smaller speed for longer time. So the smaller speed counts more. The same is in cycling races. So for example, when the track is hilly in mountains, so cyclist can ride downhill very quickly with great speed, but it takes a short time, whereas it's for much longer, it takes him much longer to ride uphill with much smaller speed. And so the average speed of the mountain stages in, say, Tour de France are less than of flat stages. Of course, it's not only about riding a bicycle, but also in any other motion. So now let's see in which case we will obtain the expected 25 kilometers per hour. So let's say again the biker is riding a bike, and the first part of his trip he covers with average speed 30 kilometers per hour, and this is half time of his trip, and then another half time he rides with average speed 20 kilometers per hour. So so now the distance is different, but the time is the same. So this is half of total time, t1, and it's equal to another half of the total time, t2. So let's call them just t. So the formula for average speed is still the same, total distance divided by total time. So s1 plus s2 divided by t1 plus t2. So now s1 plus s2, we can do nothing for now, and t1 is t, t2 is t, so t plus t is 2t. And again, we need to use the equation for speed from the first part and second part to get rid of some unknowns. But now I will calculate distance of this part. So s1, if you multiply by t1, is just v1 times t1, and t1 is t, so s1 is v1 times t, and by analogy from the second part, s2 is v2 times t, and now you plug these things in for s1 and s2 here. Okay, so what you have? You have, instead of s1, I write v1 times t plus s2 v2 times t divided by 2t. So now t is a common factor. So t times v1 plus v2 divided by 2t. So again, multiplication by bracket and multiplication, so t cancels out, and you have v1 plus v2 over 2, and this is a usual arithmetic mean. And if we plug in the values, we have 30 plus 20 divided by 2, so 50 divided by 2, 25 kilometers per hour as expected. But this result is only when the time of the two parts is the same, not when the distance is the same. So this shows also that we should be careful, and our intuition is sometimes wrong.